8C. Friction. 8.8 friction defined. Have you ever wondered how it is possible for you to walk? According to Newton's first law, if there are no unbalanced external forces on a person, he cannot begin to move. Consider a woman standing in the middle of a driveway. What are the external forces on her? The force of gravity pulls down on her, and the normal force of the ground pushes up. Neither of these forces can propel her forward. The force exerted by her leg muscles is an internal force and cannot change her motion directly. How can she create an external force? Newton's third law answers this question. As the woman attempts to walk, her leg muscles, through her feet, exert a force backward and down on the pavement. The pavement therefore exerts a force upward and forward on the foot, ultimately propelling the woman forward. The upward component of this reaction force is included in the normal force. The forward component of the reaction force is called friction. Without friction, the woman could not move forward. Ice is an example of a nearly frictionless surface. Suppose the woman were in the middle of a smoothly frozen, frictionless pond instead of in a driveway. She could try to exert a backward force on the ice, but her foot would just slip backward. She could still exert a downward force on the ice, and the ice would push back with an equal force. But unless there were some frictional force, she could not move forward. Another kind of motion that is impossible without friction is rolling. As a tire rolls, it pushes backward on the road. Consequently, the road pushes forward on the tire. This forward force of friction moves the car forward. When there is little friction, on an icy street, for example, and the car's tires spin, they exert little or no horizontal force on the ground. The car cannot move forward on level ground when friction is absent. Similarly, a wheel on a frictionless incline will not roll, but will simply slide without rolling. The friction that makes walking, rolling, and similar motions possible is called traction. Traction is also the name used for friction that prevents unwanted motion. For example, when a car rounds a curve, its tendency is to continue in a straight line. Traction provides the centripetal force to keep the car on the road. Sometimes traction alone would not be adequate to change the car's path. In such cases, the curve is often banked so that a component of the normal force also points toward the center of the curve, adding to the centripetal acceleration caused by traction. Friction does have positive aspects, but sometimes it gets in the way. Friction is, in general, a force between two surfaces that opposes the relative motion of the surfaces. Every time one surface slides across another, for example, across a carpet, the sliding object exerts a force on the other surface in the direction of sliding. The surface therefore exerts a reaction force on the sliding object to oppose the sliding. Friction occurs because of the interaction of molecules of the two surfaces. The closer together they get, the stronger the interactions become. If you smooth two surfaces, at first you decrease friction by removing obstacles to the motion. Just like removing speed bumps on the road allows a car to travel faster. However, when the surfaces become smooth enough for most of their atoms to touch, the atoms attract each other, increasing friction. Try sliding apart plates of glass that are stacked together. 8.9 Magnitude of friction. What affects the magnitude of the friction force? Consider two boxes of the same size and material but different weights. Both are pulled across the same surface. Which experiences a greater frictional force? The heavier box does. Apparently, weight affects friction. Suppose a rectangular box is dragged across a surface, first small side, then on a large side. In which case is the frictional force greater? On an ITT is the same in both cases. The frictional force is not affected by the area of contact between the surfaces. Now suppose a box is pulled across a level surface and then across the same surface inclined to the horizontal. In which case is the force of friction greater? It is greater with the level surface. One force that is related to weight and that decreases on an incline is the normal force. It seems reasonable to assume that the normal force and the frictional force are related. In fact, scientists have found experimentally that F relate N. This proportion can be written as an equation by adding a proportionality constant F equals mu times N, 8.2. The constant, the Greek letter mu, U, is called the coefficient of friction. There is a characteristic coefficient for each pair of materials in contact that must be found by experiment. 8.1 Kinetic friction. The force of friction on an object depends not only on the object's weight and the material it is made of, but also on the object's state of motion. You may have noticed this already. For example, more force is required to start heavy box moving than to keep it moving. Therefore, for each set of materials, there are two coefficients of friction: the coefficient of moving or kinetic friction, mu k, and the coefficient of static friction, mu s, usually mu s greater than mu k. For the magnitude of kinetic friction, Fk, F equals mu kn, 8.3. Kinetic friction has several properties that generally hold true, although there are exceptions. The kinetic frictional force is oriented parallel to the contact surface, opposes the motion of the system of interest, depends in some ways on the kinds of materials in contact and the condition of the surfaces. This property tends to be highly variable and dependent on other factors, is generally independent of the relative speed of the sliding surfaces, as long as the characteristics of the surfaces remain unchanged, that is, no phase, structural, or chemical change occurs that might alter the surface material properties. Is generally independent of the surface area of contact between two objects. Is directly proportional to the normal force acting on the sliding object. 8.11 Static friction. However, for static friction, Fs, friction between stationary objects, it is not necessarily true that Fs equals musn. When two surfaces attempt to slide against each other due to a shearing force, friction will prevent them from sliding until the applied motivating force, parallel to the surfaces, exceeds the static friction. In other words, static friction can vary from 0 up to a maximum value, Fs max. As a mathematical expression, 0 less than or equal to Fs less than or equal to Fs max. As long as the applied force parallel to the surfaces is less than Fs max, static friction will exactly cancel out the applied force, and the surfaces will not slip. Only when F greater than Fs max will the surfaces begin to slide. The magnitude for maximum static friction between two materials in contact is found from Fs max equals musn, 8.4. Static friction also has properties that are generally true. Experimentation has shown that static friction can be any value between 0 and a maximum value characteristic for the two materials in contact, is oriented parallel to the contact surface, opposes the motion of the system of interest, depends on the kinds of materials and condition of the contact surfaces, is normally independent of the contact surface area.